welcome you all on behalf of TI, and thanks to Linux Foundation for giving us this opportunity. I'll keep this keynote very simple, and I'll make the intention here is to talk about me, myself, and with Zephyr, like how we are going together. So basically focus on a developer view, like what we can achieve with Zephyr today, and where is Zephyr and what we can achieve by using Zephyr, and what does industry expect from Zephyr, a manufacturer's view, whether it is a semiconductor manufacturer or a platform or board or a SOM kind of manufacturer, and an end manufacturing segment, like if you are if one is building their industrial equipments or automotive and things like that. So what they expect from Zephyr today, and what can we do together as a community. So the way we all have met today, so it shows the interest in developing something around Zephyr. So what does it mean, and what exactly we can do together as a community. So what can we achieve with Zephyr from an industry, community, engineering point of view. So you all, like as you all know and I know, open source Linux style operating system Zephyr, right? So I remember like when I maybe somewhere around 2016 or 2015 I was working as part of Linaro, and then we had started this Zephyr group in Linaro at that time, and I was completely blank like what exactly they are trying to do in an RTOS segment, when it is to me RTOS was always a bare metal concept. I can simply start my C file and do star unsigned int star, give the register address and write whatever I want to write. So that's how I have done RTOS programming all my years. And then when there was concept like we will have DTB kind of file, we will have device tree blobs, we will have stack, and we will have these kind of Linux concepts into microcontroller segment, I was little bit surprised, like why do you need that kind of complexity for a microcontroller programming, where hardly there may be like 15 to 20 registers to program and very limited memory, internal flash, internal RAM, that kind of thing. So why do you really need a sophisticated complex distribution of Linux to go into MCU segment? So but that really changed my perception of how these MCUs evolved within last 3 to 4 years. So when I look at Zephyr today, like, and with the backing of Linux Foundation and Linux community to Zephyr, I can clearly see, like, if somebody is getting on to Zephyr, few things which they get, or few things that we can achieve with Zephyr is one, trust, stability, and productized solution and engineering opportunities, right? So the way Zephyr ecosystem is evolving, there is a lot of opportunity from an engineering point of view to go explore various stacks that are getting added on this operating system, tools that are coming along, profiling opportunities, like making this RTOS really stable and applicable for various range of devices, right? So today Linux runs in car, right? Linux runs in your like any sophisticated, time critical, complex device you see today, Linux runs in those devices. So like whether it is a robotics application, machine critical application, like time precision technologies, we trust Linux today. When we say in 150 microsecond or millisecond there should be a response, Linux is giving that response today, right? And if we think that it is a secure solution, definitely there is a secure solution that has come out from the Linux team. But if you see, the code is completely open. Anybody can see what exactly has gone into the code and what exactly has gone into the product. But still, when Linux gets bundled into a product, the security aspects, the real-time aspects are not lost in the transition, right? Similar experience can be achieved with Zephyr in its current form. So the trust that industry has on Linux today, the same trust can be available or made available with Zephyr. And you can get into productization of your devices with Zephyr as the core operating system. That's the core thing that I would say, like what one can achieve from Zephyr. right? And with Linux Foundation as backing, so what does it mean, right? So there is a very clear plan of how we want to take Zephyr to production. Like, what are the key gaps that we have in the offering? Is it certification? Is it making like your CVEs available, right? All the security, CRA, IEC, that kind of things that are coming in, like all the security regulations, we want to manage it. And long-term support and long-term maintainability. Generalizing, it is not tuned to a particular organization or a manufacturing unit or something, right? It is a general purpose operating system meant for all. It can scale from a toothbrush to an aeroplane kind of thing, right? So that kind of that kind of complexity can be solved with Zephyr today. So productization is possible, and with Linux Foundation backing, there is a very clear plan to make Zephyr successful in each of these areas, whether it is safety or security or low power, integration of connectivity. So each of these things, there are separate projects which Linux Foundation is hosting, and there is a very clear direction that is being set. There are invited members. There is lot of evangelism that is being happening with help from Linux Foundation. So these things are very, very important to make an operating system successful or make an ecosystem successful, right? So this is one key thing I would attribute to Linux Foundation. And second thing, as I was saying, the software that is going into the product is reviewed by multiple community contributors, right? This plays a very, very significant role when we are developing software. Today, when I develop software and I am pushing it to my own GitHub, and how many reviews have happened for that software, like what kind of checks and balances has gone in before the software gets into my repository. If you see, like if from TI, if we have a team of 4 to 5 people working on particular operating system, then the review is happening only between 4 or 5 people, right? And hardly we get that opportunity or time to really go deep, look into the design, look into the artifacts, look into the kind of the structure that we would have put for the code, the optimizations that we might have taken into account. All these things will be limited to only the 3 or 4 people who are working on the project. When you work on this kind of a large scale operating system, which is completely community driven and community written, and when there are maintainers for these projects who are clearly putting the boundaries or rules of engagement, that now makes the software code very, very stable and sustainable for long term, right? We say that, okay, to get this code into a community repository, it would take lot of time, but there is a reason for that, right? You are going through a very good check of the code, like what Linux does with Linux device drivers and all the protocol stacks and things. Similar checks and balances are happening for Zephyr that gives very good stability of code. This is very important from an industry point of view. So quality of the code is met, the code becomes robust, and code becomes generalized. So it is no more tied to only particular particular SOC, particular product or a platform or board. It now becomes available to all the platforms, agnostic to any SOC vendor, agnostic to any platform. And Zephyr gives you pre-integrated software stack. So if it comes into connectivity or power management or security, so it's not just about writing into the register to get writing into the registers and get the registers programmed to do some minor functionality, right? It is now developing the stack above it, and what comes at the driver layer and what comes into the HAL layer and what comes into the user space and what type of applications are getting written. So all these things matter. So the end-to-end solution should be feature complete. So only when it is feature complete, then you can take this solution into an end product, right? So Zephyr gives you a feature complete end-to-end software stack. Then comes board, ecosystem, SOCs, platforms, and all these things, how they get collaborated. So today, on Zephyr, you can start with a very simple microcontroller to a large scale multi-core SoC. So Zephyr can scale from different megahertz of microcontrollers to gigahertz of multi-core SoCs, and internal RAM to an external GBs of RAM, internal flash to an external eMMC. So pretty much every range of protocol stack, every range of hardware has been checked out with Zephyr. So that makes it more robust for any kind of use case and any kind of system design. So these are some of the key areas that I identified as what one can achieve by getting into this Zephyr ecosystem, whether you are a manufacturer or an engineer or a platform manufacturer or end product or end equipment manufacturer. So the adaptability of Zephyr, like as I said, I really don't remember like exactly when Zephyr was launched, which year. Maybe one of you may know in audience, but I'm observing this at least for last 10 years how the growth of Zephyr has been. Definitely the pace is good, but then still the question that comes is Zephyr fitting all my needs, right? And what is challenging, or where is industry today in adopting Zephyr as a default operating system? Today, if I define any product by default choice, my default choice is Linux, right? When it comes to high level operating system, very rarely I might go into another operating system because of maybe hardcore real time or hardcore safety applications or very secure or high secure kind of applications. I might switch to a different operating system, but majority 99% I might simply go pick Linux and start working developing my product or end equipment, right? So is Zephyr that today, from when it comes to MCUs or microcontrollers or even microprocessors, is Zephyr the default choice of the operating system today? It is not, right? So what is the dilemma? Why is industry not in that mode of adopting Zephyr for all set of applications? So when you look into the anatomy of any processor, so we are dealing with MCU only kind of devices where 32-bit or 8-bit or 16-bit kind of microcontrollers, and then on one side you have microcontrollers embedded with microprocessors. This is another type of SoCs. And then you have microprocessors and microcontrollers and accelerators. To give an example, M4 from ARM can be a microcontroller, like only M4 can be an independent microcontroller with its own peripherals, and Zephyr can run on it. Now I can have an SoC where there is like quad A53, quad A55, quad A72s kind of thing, or octa or quad or whatever, and then I can have MCUs as an add-on which does some kind of real-time applications or real-time monitoring of a sensor and things like this. So that becomes MPU and MCU solution in one single SoC, and Zephyr can also run on these SoCs, right? And then there are solutions where I have microprocessor like A72 or A53 or A55. Then I also have M4, R5 kind of core for additional processing. And then I also have some dedicated accelerators, like I want to monitor a camera sensor, like I want an ISP, image signal processing, or digital signal processor, or an analytics processing NPU or such things. Even in that you will have microprocessors or microcontrollers, right? Now in that microcontroller I need an RTOS, I need a bare metal operating system, or I have drivers there also, right? In each of these areas, whether you are an independent MCU or MPU plus MCU, or with MPU or an accelerator, all three areas you need an RTOS to run. Now where all do you want to deploy Zephyr? Do you want to deploy Zephyr on A-core? Do you want to deploy Zephyr on only MCUs where MPU and MCU is sitting? Do you want to deploy Zephyr on an accelerator? And what advantage does it give us? Right? Zephyr on an accelerator where I am supposed to only monitor an image sensor to process that image processing, or when I am supposed to do video processing or audio processing or audio algorithms. Does Zephyr make sense? Should I put the Zephyr stack there? What value is Zephyr bringing to me there? So that becomes a question to an industry or an SOC manufacturer or somebody. Why should I pick Zephyr in these areas where I don't need connectivity, I don't need tools, I don't need profiling, I just need very bare minimum RTOS, which can allow me to do maximum 2 threads. One thread plus another thread, 2 threads, right? 2 threads or 3 threads kind of thing. So why do I need a sophisticated Zephyr kind of operating system where I need to define the device tree blobs, where I need to configure the pin muxing, where I need to have connectivity, where I need to bring in security and such things, right? You really don't need in such cases. So this is one dilemma from an industry point of view. Like, why should I deploy Zephyr in standalone MCU? Definitely 90%. Okay, go ahead for this. MPU plus MCU, do you really need Zephyr on that MCU? Question mark, right? And when you have MPU, MCU and accelerator, in accelerator is Zephyr important? Maybe not, right? So in these two areas where MCU is sitting next to MPU and MCU is sitting as an accelerator, there is Zephyr an important operating system. This question is not very easily answered by the community to the industry. Therefore, industry is in a dilemma, right? And then is Zephyr easy to learn? Can I leverage Zephyr for my product today? So if you see on Zephyr side, how is the industry moving? Like, there are engineers who are very good in MCU programming who want to adopt to Zephyr for an MCU product, and there are engineers who are on Linux, like there are super Linux engineers, and they want to program MCU. They want to use MCU as an accelerator or for some additional programming, right? How do you serve these two engineers? Like, just from an engineering point of view, if I see MCU engineer who knows bare metal, star unsigned in star address equal to some value, like he knows how to write very good logic, very good if condition, while functions and such things. He is very fluent in hardware understanding, right? He knows what register to program when in the sequence so that the hardware behaves properly in the with the given latency and such things. So how easy it is for this person to adopt Zephyr? In my view, it is little bit complicated at this point. The way Zephyr is organized, the way Zephyr allows you to deal with your hardware and platform and SOC, it is not so easy when it comes to an MCU engineer to adopt Zephyr, because he has no clue of what DTBs mean, how to use profiling tools, how to use, like, there are so many things in Zephyr which this person really doesn't care. Why should I fit into this kind of framework where I am supposed to write only 4 registers to get my flash working? Now you are telling me to write this in HAL under an HAL layer, follow this driver architecture, and then make sure and test it from an application layer to write access to this. User is not used to these kind of hierarchy in software. So how do we make Zephyr easy for these kind of engineers who are coming from an MCU world? From Linux to MCU world, Linux engineers are very well aware of how to configure DTBs, how to use all the tools, how to do all these things. They are very super engineers who can understand how to play with Zephyr, but MCUs are completely new to them. When you are dealing with MCUs, you don't really have to do a lot of things to program them, right? They are very limited functionality, and the system use case is very, very simple. Maybe that MCU is supposed to monitor only one ADC when A core is sleeping, right? On an event, just wake up the A core. That might be the responsibility of an MCU. In order to do that one simple functionality of keep monitoring the ADC, when the threshold increases, just wake up the A core. In order to do that, do you need to bring in this entire big stack of Linux onto Zephyr? So that becomes a challenge for Linux world to adopt MCUs, right? In an MPU context. And is Zephyr ready today for taking it into car? Can I build my airbag system in car today to use Zephyr as an operating system for my real-time use case? So this is the question that comes, right? The industry, so the car that is going to come in 2030 or 2029 is getting designed today, right? You all agree, right? The robots which are going to perform surgeries are getting built today. That means they will get into use maybe 3-4 years down the line. They all have to go to the certification process, quality, robust testing, hardness, and all such things has to happen, and only then they can come as a product in the industry, right? Now that is a 3-year, 4-year journey. Now Zephyr is needed today if you have to see the product in next 3 years, 4 years. So somebody designing an airbag system, somebody designing a high precision robotic for medical equipment, such places, can I blindly, without even thinking, take Zephyr and put it on my microcontroller? How many of us, like, you are Zephyr users now, or you are Zephyr community, right? If your industry veterans or your managing directors, your CTOs come to you and say, like, shall I take Zephyr and put it on my airbag? What do you say? You are laughing, come on. So there is this still dilemma, right? Like, should I say yes or should I say no? You don't know when you get into certification, will you get certification or not? There is some still that glitch, right, in our heart and mind, like, should I propose or should I wait? We will say, like, wait for 1 more year or 2 more year, let the stability, or let us see more use cases, let's see how the systems are getting, let's see some real world examples, right? And then we pick this. So that real world examples are missing today. We need to talk about it, right? That's another thing which is definitely holding the industry in running with Zephyr. And what should the industry do? Start investing full-fledged and do everything by themselves, or rely on ecosystem? Now, if some university students are doing, or some freelancers are doing their own Zephyr contributions and things like this, should I simply wait and see the maturity and evolvement of Zephyr and then go pick it? Or should I start now investing on Zephyr and do everything on Zephyr? So this is one question that industry is asking. Is Zephyr a business loss for me? Like if you are developing a product, and if you go to the website, and if it says, like, this is the processor, it has Linux, it has Android, it has QNX, it has FreeRTOS, it has ThreadX, it has all these things, and there is a Zephyr missing, do you still go with this product, or you say, like, no, Zephyr is my top one item? Like, if there is no Zephyr, I am not going to pick this hardware, or I am not going to pick this SoC to develop my hardware. Is that a business loss, or is that a important item in my RFQ, right? So if that is, then industry will move fast to Zephyr, right? It is not a de facto thing that everything should be built on Zephyr. So that is one question that always comes. So these are some of the factors that I identified when it comes to industry's dilemma in why we are not moving faster on Zephyr. So we should get there for sure. I told all the benefits of what you get if you adopt adopt Zephyr and take Zephyr into your ecosystem or in your product. Definitely there is lot of goodness into this, right? But there is lot of work to do, and for that work to do, lot of us in this room have to work hard to make that successful, right? Like Linux today, where it is, I was working on Linux 2.6 somewhere around 2001 or 2002. So from 2.6, if you see the history of Linux, if you see Linux kernel version, the 2.6 variant stayed for many years. They didn't move to 3. 4. 5. 6. kind of thing very soon. It was still maturing slowly for that first 10 years, and then after that it picked up so fast that it, like, we had to give version numberings at fastest pace, because there was so much lines of change of code that was coming into Linux every month on month or quarter on quarter, right? So that level of evangelism should happen for Zephyr as an RTOS, right? To make it like a default choice for any of these things. But remember the question that I asked, right? Should I take Zephyr into an MCU where that MCU is supposed to do only an ADC check? Do I need to take Zephyr there? Does it add value? So, but if you see an MPU where it is a processor, Linux is a default choice. There is no other way you can quickly do either Linux as a real time or Linux general purpose. You should take Linux. But in Zephyr, you have a choice. You can see that really if it is complex, yes, I will definitely take it. But if it is a standalone MCU, maybe I will definitely take it. But if it is an add-on in my high-end processor, maybe may not be, right? So therefore your reach may be limited with Zephyr, unlike Linux. The second thing that we should do together is, which is very, very important, we are allowing a lot of different practices to come in Zephyr today. Like if I see, this is my common debate that I have in TI also when I'm working with Zephyr teams. We develop driver one time and we give that driver for bare metal, like run as is without any RTOS, run with free RTOS, run with ThreadX, run with Zephyr. So I develop driver one time and it runs across all the real-time operating systems. I have an HAL that makes my driver easily attached to bare metal, no RTOS, free RTOS, ThreadX, QNX, Zephyr. So we have put Zephyr in the category of normal operating systems, like every operating systems. Now when FreeRTOS, ThreadX, QNX are giving me this flexibility of attaching my driver which I have written for one time, why is Zephyr not giving me this flexibility to attach my driver? My driver is no different. It is just a simple C blob. I have just written top to bottom one simple C file, no structure followed, one function, two function, three function, right? I might start my function name with some camel underscore dog underscore something. It accepts, right? There is no rules followed, nothing. Like the rules are my own rules. That's how I have written my C code. Now that code I am attaching to FreeRTOS, it works. I am attaching to QNX, it works. I am attaching to non-RTOS, it works, right? And same code I am attaching to Zephyr and I am expecting it should work. Why does it work? Now it is our responsibility to push that code out. Like if you see in Linux today, we don't accept a patch if the check patch fails. We don't accept that code. Even it is one extra space, one simple space that is added, or one line breakage, not following the number of line characters in one line, we remove the code, right? But in this case, we have made it entry free because we want Zephyr adaptability and reach out. Therefore, we are bit lenient on the rules that we have put, right? But we should be very strict here. Otherwise, what happens? Your code, lot of dead code will stay in Zephyr project below the HAL as common drivers, which nobody else would be using at all. Like if you see the Zephyr driver code or Zephyr code structure, and under the HAL, if I put one directory ti_soc, and in that if I start putting all my code, which is not reviewed by Zephyr community, which is not reviewed by anybody in the open source ecosystem, and my code lies there, which only I know what I have written. Now, will this code be consumed by any other SOC manufacturer? No, right? Nobody even goes and double clicks that. That is TI code. I am not using TI SOC. Why should I go there? Maybe the code that is there, which I have written for I2C, may be super optimal code, but I don't touch it because I am not using TI SOC, right? It's not the same when it goes to Linux or something, right? All generic code is going in generic folders. So every SOC will get an opportunity to use that generic code, right? But here, if you allow non-compliant code to stay in a folder, that is creating lot of clutter in the Zephyr code base, which we need to be very careful. We should push back, saying like, okay, it may take another month if you want to write that driver as a native driver, versus you give your C blob and I fit it into Zephyr. You are understanding what I am saying, right? So we should push back. As a Zephyr community, we should push back. Don't accept that code. You say like, write a native driver. It might take one more month for you, but give that. Let everybody else in the community use your work, right? The whole intention of building this community is to do shared engineering. And if you are not utilizing that opportunity, then it is waste of time. So we all have to take ownership of maintaining the code, reviewing the code, setting the quality bar high. We all have opportunity to take the role of maintainers in Zephyr community today to make this ecosystem stronger, right? And we have to scale Zephyr, like as I said, from a normal, very simple microcontroller to a very high-end equipment, and low precision to high precision, high latency to low latency, high RAM to the very lowest possible internal RAM. For all these things, Zephyr should scale. That means you need to deploy Zephyr on various types of hardware, various type of platforms, right? And it is not easy. Like being in TI, I can't make 100 boards to check Zephyr for all variants of DDRs that are available in the market, all variants of flash, all variants of Wi-Fi solutions, Bluetooth solutions, all these things, right? So we can't do that. But if you leverage this ecosystem, maybe a Wi-Fi solution of some other SoC will get validated on, and I can take that stack and put it on TI SoC. All such shared engineering can be practiced if we follow a normal common open source ecosystem. So how does Zephyr matter to us at TI? We have very low cost, low footprint MCUs. The one that I am showing here, this is the world's tiniest 32-bit microcontroller launched last month by TI, and we can get Zephyr working on it. So, and then you have very high-end Beagle board, AM62 series Beagle Play, which is like MCU plus MPU kind of like MCU and MPU kind of device, where you can run Zephyr on A core or Zephyr on MCU core. So for us, Zephyr definitely matters from MCUs to MPU and high end, right? So we can deploy Zephyr on any of these devices. Again, the question comes, the questions that I get asked and I ask is all those industry dilemma that I just explained in my previous slide. We have very good partners working with us, and we leverage community, we leverage our ecosystem to help our customers to deploy Zephyr based end equipments and products, right? So this is all I had for today in the keynote, and we will open the workshop for other serious talks related to Zephyr. Very happy to have you all in TI, and on behalf of TI and Linux Foundation, I welcome you all.